Hey everyone, let's solve this question together step by step. So we have a wire with resistance R and length L. So you have a wire, a clear representation of a wire of length L and resistance R. Okay, R is the resistance, not the radius, the resistance. The wire is cut into 5 equal parts. So the wire is going to be cut into 5 equal parts. And then these parts are joined in parallel. So basically every part is taken 2, 3, 4, 5 and all of them are being joined in parallel. Okay. It's totally not necessary, but here we are. Just for visual representation. So this is basically L by 5. That's the length. Okay. So our job is to find the total resistance of the wire when it is joined in this configuration. So the first thing we need to understand is how cutting the wire into parts changes its resistance. Okay. So resistance depends on the material, the length and the thickness of the wire. So the formula for resistance of a wire goes something like R is equal to rho into L by A, where your rho is the resistivity of the material. It is a property of the material and it is empirically found. L is the length of the wire and A is the cross-sectional area of the wire. So basically this area, the area here. Okay, so now when the wire is cut into 5 equal parts, the length of each part is divided by 5. So the new length of each wire piece will be L by 5. Okay, since the wire is cut into 5 equal parts, the resistance of each part will change. The resistance of each part is proportional to its length. So the new resistance of each piece is, so let's call the new resistance R new, is equal to rho into L by 5 by area, which is nothing but 1 by 5 into rho into L by A. So rho into L by A was our old resistance. So this is the R is our old resistance by 5. Okay. So next we need to understand what happens when we connect these parts in parallel. When resistances are in parallel, the total resistance is, using this formula, 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5, because we have 5 wires, right, in this parallel configuration. In this parallel configuration, we have 5 wires in parallel and each wire resistance we found here as R by 5. So when we say 1 by R by 5, and since all of the wires are equal, we can simply multiply that by 5. Adding it 5 times is basically multiplying it by 5. So this is a little complicated fraction. I take this 5 here into R by 5 in the denominators becomes 5 by R, which is 25 by R. So basically you found that 1 by R total is 25 by R. So flipping both sides, we get R total is equal to R by 25. Makes sense? This is option number 1.